Hey folks, welcome out there this afternoon. It is a great Friday afternoon, and you know what that means? Specialized Segments Day. Hey, we've got a special topic that we're going to explore it and go in depth with it. But we're glad you tuned in. It's not a call-in day, but you can still send us messages via Facebook, Twitter, also through our email. But we won't be able to address it until next week. But we thank you for tuning in this afternoon. We've got some good stuff for you, some great problems. Today you get to sit back, relax, and let me, Ernie Roberts, the host of TNLearn Mathline, take you through some mathematical treasures, all right? Let's see what our treasures are about today. What do we got for us, guys? Well, we're going to follow the money trail. Follow that money trail. And you know what? Treasures. Just so perfectly laid in there, all right? So the money and the treasure, you say, Ernie, what in the world are we going to do? We're going to look at systems today, and we're going to see applications for solving for systems of two variables, x and y, and linear equations, all right? And we're going to see how they work together. And you say, what does money have to do with it? You're going to see the problems are all about money today, all about money. So sit back, let's earn some money, let's earn some fun, and let's see what our first problem is. It says Mario, he's got coins in his bank, maybe a piggyback, I don't know. It says the coins have a value of $4. They are either dimes or half dollars. So we're getting clues. All right, we're getting great clues on this. And with Mario in his bank, we've got 20 coins. Again, they have a value of $4. They're either dimes or half dollars, all right? So we got two types of coins here. Hey, two variables, all right? So we want to know how many of each type of coin does he have, all right? We're not saying we have a specific amount that they're equal, okay? We don't have an equal amount of money here. We may or maybe not. We're not saying they're both $2 each, all right? We're saying what happens here is we add the results together, we will have a total of $4. So I want to just take a few of those myths out of your mind right there off the bat. Two important numbers, 20, $4, and this fact here, dimes, which we know are how much? 10 cents, and half dollar pieces, they are 50 cents, okay? Half a dollar, hence 50 cents. So here's what we're going to do with this. We're going to set up two equations. We're also going to set two variables, all right? Because we have two variables, we have to have two equations. So let's start it right off here. First of all, we've got D. How about we'll let that be the number of dimes. And we've got H. We'll let that equal the number of half dollars. Makes sense, doesn't it? And that's what we like to sometimes, if we can, be able to use the first letter of what we're looking for, okay? So D is a nice representation for dimes. H is a nice for half dollars. But folks, we are defining our variables right off the bat. That's what you got to do. You want to make sure you do it right up at the beginning. Because then, when you start pulling these clues involving the variables D and H, oh, it's so much easier. So much easier to pin these things together. So Mario, you got 20 coins. What's that about? That means you have dimes and half dollars. If you shake them all up, you're shaking up 20 coins in that bank, all right? So let's see. That tells me if I take the number of dimes plus the number of half dollars, I'm going to have 20. There's my first clue, first equation right there, okay? Second equation, what are those dimes and half dollars worth? We're going to talk about how to make $4 happen. Well, we know that a coin that's worth a dime is worth 10, all right? So we're going to put 10D. We're going to pick up 50 cents for each half dollar. So we're going to get 50H. And since I'm going to avoid the decimals, okay? I could have put 10 cents with the decimal. I could have put 50 cents with the decimal. But I'm just going to say I've got 10 cents, whole number, integer value here. 50 cents, because some of you like that. But we've got to fix this to make that become 400, because now we're talking about I have 400 cents, okay? Which is equal to $4, all right? So I want everybody to understand that's my numbering system here, all right? So the question is, what's the smart way to do this? Well, we could do substitution. We could get D or H by itself and do substitution. We could also line them up, move them out like we did last week with an elimination approach. I'm going to go elimination, all right? Because this one is kind of begging me to do that. It really is. So we're going to put a negative 10 right out there in front because I'm going to get the D's to eliminate. You say, well, Ernie, could you have gone for the H's? Could you have multiplied by negative 50? I could. But what's going to happen there is I make bigger numbers, and sometimes bigger numbers may allow us to make bigger mistakes, all right? So we want to make this as small and possible as we can. So this is a negative 10 out there. Sometimes my negative 10 gets a little bit blurry, but that is a negative 10, not a 70, folks, okay? Those of you who are just tuning in. We're going to run this negative 10 all the way through. We can't just stop at D and H. This is called the multiplication property of equality, and everybody has to be hit on both sides of the equation, all right? Now, the one down below it, we are not going to mess with that. We've got a negative 10D here. We've got minus 10H, and that's going to equal to negative 200 right out there. That's our change. That's our transformation. Notice I like using these arrows to point where we're going. We're getting a transformation, getting to a new equation. Now, did we transform anything here? No, we're just multiplying by 1 through everything, so we're going to get the same thing right back. We got 10D plus 50H equaling to 400. Now again, some of you may be tuning in there and finding out, now why did you multiply by 10 at the top or the negative 10 by the top? I want these two to cancel out, okay? That's the idea. I want to eliminate, move them out, okay? Get rid of them. So here's what's going to happen. We're going to be able to add these two equations together. Just draw a nice line there. Notice the D's, goodbye. And over here on the H's, we have 40H equaling, subtract 200, because that's a negative 200 up there, my friends. And that's going to leave us with 200 down here, positive. Now remember, you're counting how many coins you've got. So this answer should be positive and it should be integral. You can't have 2.5 quarters or 2.5 nickels or 2.5 dimes in this case, or 2.5 half dollars. You've got to have you've got to have positive integers for your answers on this. So be sure that's happening. It is going to happen because 40 divides in there nicely. That's going to give us H equal to 5. So right now it looks like we have 5 half dollars. So I'm going to put right over here, I'm going to put a 5. Circle it, let us know that's for half dollars. The D value, my friends, what do you know? You've got 20 coins. Well, 5 of them are half dollars, so that leaves the rest of them to be dimes. And subtract 20 minus 5, you're going to get 15. Now, the question is, that looks good, 20 coins. We did that good. We did that very well, all right? Now, where we've got to go from here is, do we get $4 back? Do we get $4 back? So let's think about it. 15 dimes, that's going to give us $1.50. $1.50. And let's see. Ooh, what is 5 half dollars going to give us? That's going to give us $2.50. Everybody with me? Everybody with me? Put these two together, my friends, we have $4 back. That's what we're looking for, all right? That's the magic of these things. Now, our answers need to make sense, and that's why I go back and say, does it satisfy? Does this pair satisfy both clues? We had 20 coins. That looked good, 15 and 5. Did we come back with $4? That was the second clue. Yes, we do. So we know that's the combination that Mario has in his bank. Way to go. Follow that money trail. See where those dimes and half dollars are going to go. Good job right off the bat there with a little bit of money. Let's go to another one here. Here's got Kai and a stack of 25 bills, and that's money, all right? We're talking about dollar bills of some sort. Here we're going with some are $5 values and some are $1 bills. And he has a total value of $77 when the smoke clears if he adds them all up. What we've got to figure out is how many are in each stack, all right? So let's go with, first of all, let's go with some $5 bills and some $1 bills. And since B and B don't really make sense to use the same variable here because there are different variables, let's just use X and Y. All right, we're going to let X equal the number of 5s. And we're going to let Y equal the number of 1s. And that means, folks, that means $1 bill and $5 bill, okay? So, according to this, Kai has a total of 25 bills. So your first clue is saying, let's do it. X plus Y equaling to 25. There's your first start. See how easy that was? Just because you knew you had 25 bills. So Ernie, it kind of sounded like that other problem. We had 20 coins. Yeah, we just added X and Y, or in that case, what was it, H and D, and we got the 20. Okay, so it's the same story here. It's just a little bit of different wording, but it's still money, still about money. Now, again, what do we say? Our X is going to be $5 worth each time. So guess what? We're going to have a 5X, 5 times $5 worth times the number of bills. And $1, so we're going to have 1 times Y, which is pretty straightforward. So we're going to put a plus Y here. And that is going to equal to 77. How nice is that? That looks really good. One thing I really like about it, I'm seeing these y's stacking up here. All I need to do is change one sign. And you say, well, Ernie, which one are you going to do? That's a real good question. Let's go for it. Let's do the top by -1. We're going to multiply it by -1 because all I need is a sign change. You say, well, could you multiply by -5? You could have, but you don't need to go there. All you need to do is change your signs. And dear friends, this is one where it's very critical. Make sure when you do that transformation, everybody's signs change, all right? So we're going to have the opposite of x, a minus x as we like to call it. You can put a minus 1x if you want to put on there. And we're going to put minus y. And we're going to have -25. Notice 1, 2, 3 sign changes. Make sure they all do it. Multiplication, property, equality, rocking your world there if you don't, all right? Especially if you leave it out. If you don't get all the way to the end, you're really going to have a mess. But let's pull across here. We got 5x, and we got plus y, and now we still got our 77. See, the second, we didn't need to move anything. We didn't need to multiply. We didn't need to change signs. We just bring it across for the fun, all right? Let's add them together and see what happens. The y's, say goodbye to them. They're going away. They're going away. They're going to cancel. Over here, we're going to have 4x. We're going to have 4x. Everybody get excited about 4x, all right? And now let's subtract 25 from 77. All right, what have we got left out there, arithmetic geniuses? Every one of you all heard. Tuning into Mathline, you know how to do arithmetic, right? I believe we're going to have 52, all right? And when we divide 4 into 52, it goes evenly. That's a good news moment. Because remember what I said earlier. These have to come out even, have to be integers. So let's divide by 4. And it looks like x will be 13. 13. Everybody with me so far? All right. So now it's time to check it out. So we had 13 $5 bills. That's what X stands for, right? Hang on there. That means if we have 25 bills, well, what have we got left over? Subtract 13 from 25. That will give us 12 ones. My question is, will we come up with 77? That's our next game plan. If you take 5 times 13, 5 times 13, you get $65. If you take, well, this is ones, right? So 1 times 12 gives you 12. You add those together, you get 77, and that's your check right back there. You already know these add together, you get 25. All right, so there it goes. And it satisfies both requirements. So Kai, looks like you got $5 bills, 13 of them, and 12 ones up there, all right? So remember again, that's why we define our variables. So when we go back and check at the end, we know which one to put in the right place, okay? It does make a difference. Does make a difference, all right? Let's talk some more money. Let's talk food and money. Ooh, food and money. Here we go. A fast food order of $20 covers 10 hot dogs and 20 burgers. If y'all aren't getting hungry, I sure am. 10 and, oh my goodness, this is like feeding a family of 30. Let's see what happens on the other thing. A $17.50 order covers 20 hot dogs and 10 burgers. What is the cost of each food item? I have a feeling these are small burgers, small hot dogs, because these don't look like they're going to cost an awful lot out there, folks. We're going to find out. Let's find out how much they're going to be worth here, all right? So first things first, H and H, they both sound alike to me. So let's just use X and Y on this, all right? So we're going to let X equal the number of hot dogs? No, we already know the number, don't we? Let's not put that in there. Let's back up a little bit. It's going to be the cost of a hot dog. All right? So again, don't always jump in the fact that, oh, we had 2 problems just like that, so we're going to put number of. Read your context. Read your context of the problem. This time, you're trying to figure out the cost of each item, all right? So guess what? We're going to let hot dogs, since I put hot dogs in as X, let's let Y be the hamburger cost. Okay, so it's going to be a cost of a hamburger. Now, again, remember I said, got to have 2 equations because we got 2 variables. So that means there's 2 clues. And according to this, we got a $20 order and we got a $17.50. I guess this is probably before tax. We're not going to worry about tax issues here, okay? We're just going to take it with what the information's been given to us here. So we're going to say 10 hot dogs and 20 burgers gives us how much? It's going to cost $20. So here we go. 10x plus 20y equals, what do we say, 20. So far good? Everybody good? Work these along the way now. That's the good thing I forgot to tell you, get that pencil and paper out. Boy, you're needing it today because this is some good heavy problem work here. How about it, the $17.50 order? 20 hot dogs. So we're going to do 20x plus 10y, 10 burgers, gives us $17.50. Now, just to make us feel comfortable, I'm going to put that out there because sometimes people put the 20 in the wrong place. I don't think you guys would do that. Those of you who watch on the Fridays usually are with it pretty well, okay? Now, let's see where we're going to go with this. I am going to take and figure out how can I get the y's to cancel, or how can I get the x's to cancel? I'm going to go with the y's, all right? And on this one, it really is the infamous 6 of one, half a dozen of the other, because if I multiply this top by a value to make the x's cancel, in other words, I'd multiply it by -2, or I can multiply the bottom by a -2 and leave it, so I'm going to choose the bottom equation, all right? So we're going to put a -2 there. And we are not going to worry about anything in the top, all right? Because those x's are going to take care of themselves. Let's see how this works. First of all, the top stays the same. So we got 10x plus 20y equaling to $20, okay? Well, that was easy. Over here, we have double everything. We're going to have a -40x minus 20y. And that equals, I believe that's going to be 35. Now, dear friends, remember what I've told you over and over we're going to do. We got to make that go a -35. $35, okay? There we go. Now, let's line them up. Say goodbye to your y's. Goodbye, y's. Now, let's see what we got here. We got -30x. Like I said, the y's are gone away. And we're going to subtract out. We're going to subtract out 20 from 35, which is going to give us 15. Now notice some of you are going like, but Ernie, it's a -15. And that's good news. You say, why is that good news? Because I'm going to take a negative into a negative, which is going to give me positive. That's what I have to have. That's what I have to have. So let's see where we're going on this. By the way, we're talking about money, right? It's got to be positive, and it should come out hopefully fairly even, all right? Not evening yet, but even, all right? Let's take that -30 into the -15, and it looks like we have a 50-cent hot dog. That's what I'm catching, all right? Because 15 divided by 30, that's going to give us a half, all right? -15 divided by -30, it gives a positive half, all right? So there's 50 cents. So here's where things get a little interesting. Let's go back and take that 10 times 50. We're going to take this, bring it right down here, and we're going to substitute what we know, which is 50 cents. And we're going to add 20y to that. And hopefully we have a $20 cost. That's how we're going to figure out what's going on, okay? What's our cost of a hamburger? By the way, remember that's 50 cents. Let's put it right up here so we don't forget, all right? We'll put our 50 cents right there. Now, cost of a hamburger, got to get rid of the hot dog cost first. So that was $5. 10 times 50 cents, all right? And we got 20y hanging on, and over here we got $20. Let's subtract that $5 there, and that's going to leave us 20y equaling, looks like $15. We like that 15 today. And I'm going to do a quick divide, and I believe we're going to have y equaling 75 cents there, all right? So there's our hamburger cost. Like I said, these are not probably your big deluxe burgers, all right? These are probably fairly small for the prices that we're paying here. But we know that works. We know that works. Let's test it out on the calculator. Since I'm about out of room here, let's go to the calculator and see how that works, all right? We're going to take our 10 times 75 cents, put the decimal in there, and then we're going to add. We're going to find the add first. There it is. There's the add. And we're going to take 20 times 75. Do that backwards. I'm sorry, I did that backwards. Let me go back here a minute. Let's go back, fix that. Put a 50 on there. All right, now clean over. Now we'll take 20 times our 75. Jumping the gun a little bit here. Twisting it up. Let's see, do we get $20? Hold your breath. We got $20. Isn't that great? So it does check, it does check. Let's check our second equation, all right? Let's take our 20 times, this time I'm going to do it the right way. We're going to put 50 cents, all right? We're going to put in 50. And some of you say, could we just put 5/10? Sure, you don't have to put that 0, but since it's 50 cents, I like it. And this time we're going to add, this time we're going to use the 10. All right, everybody with me? 10 times what? 75 cents. Now this time we want $17.50, all right? Let's see if we get that. Ready to push the button? Drum roll. And there it is, $17.50. So folks, it does both check out. Both check out. Both clues come back to check out. Life is good, all right? So that when you said, Ernie, that got a little complicated. Well, you know, not everything is just going to be quick and easy and painless, all right? Sometimes you got to work for these things. Sometimes you got to work for them. Let's look at our next one here. Got Ken and Kelly, all right? And they're doing slacks and shirts, And they both start with S, so let's go with X and Y again. And according to this, it says, what is the cost of a shirt? And we'll need to also probably figure out what is the cost of a pair of slacks, all right? So we're going to let X equal slacks, and that's going to be cost. And we'll let Y equal the cost of shirts. Well, that's pretty easy, isn't it? And according to this, the storyline is that Ken bought a certain amount of stuff, and then Kelly came back and bought some different things, and obviously they paid different prices. So we're trying to just figure out, well, what does that mean in terms of real cost of slacks and shirts? So here, let's go. First clue, right there, 3X, so we bought 3 times X, plus 2Y, that's going to give us 72. There's your first equation, all right? Second one, let's go to Kelly's story. Kelly bought 5 pairs of slacks and 3 shirts, all right? So that's going to be 5X plus 3Y. And, you know, those numbers are pretty much bigger, so I expect the cost to be a lot more. And according to this, it's going to be $116, all right? So first of all, hopefully those numbers make sense to you, all right? So basically what we're saying is, slacks and shirts, we paid $72. Slacks and shirts, we paid $116, all right, depending on whose stuff you had. And you say, Ernie, we got to eliminate. Yes, we do. We want to eliminate. I'm going to go for the Y's because I'm going to notice something. 3 and 5, I need the number 15 for both of those to be able to divide into evenly, to make those eliminate. I need something like a common denominator type thing. Here with 2 and 3, though, 6 is the number I need. Oh, so much smaller. Easier multiplication, especially when we start getting these crazy numbers here, all right? So let's do the top. Let's do the top by 3. And we're going to multiply the bottom by -2, all right? And we'll see what comes out of this mess, all right? Hopefully good stuff. Remember, we want that cost to be pretty decent, all right? We're going to find out. We're going to find out. Let's distribute. Let's run that 3 through everything, all the way across, all the way across. So we're going to have a 9X. We're going to have plus 6Y equals, let's go, arithmetic guys and ladies out there. Let's see, I believe it's going to be 216. Underneath here, we're running negatives, so we got to watch your sign. That's going to give us a negative, looks like a negative 10X there. Wow. But the good news is it gives us a negative 6Y, which is going to cancel. That's what we're after. And now what we need to do, let me hit just a second here, folks. Let's get that 116. I want to make sure we get this one right. I believe it is going to be 232, but we want to make sure, as you all do too. We get 232. All right. Equals 232. So what we've got going here, by the way, that's a negative, right? Everybody change your signs. So the Y's are gone, the X's are hanging on. That's a negative X equaling, let's subtract that out. I believe we're going to have a negative 16. So at this point, it looks like, dear friends, it looks like we got $16 for our X, which is cost of slacks. So let's take it real quick here. 3 times 16 plus 2Y equaling to 72. That's going to be that's Ken's business. That's 48 plus 2Y equaling to 72. Let us subtract here, and let us subtract correctly, that's for sure. I believe we're going to have 2Y equaling, looks like 24, and Y equals to 12. So real quickly here, it looks like our slacks are 16. Our cost of shirts is 12. Let's check real quick. We know that 3 times 16 is 48. 2 times 12 is 20. That makes 72. That looks good. Go quickly here with 5 times 16. I get 80. And 3 times that is 36. That makes 116. So my friends, there we go. 12, 16, and the 2 clues are satisfied. All right. So you've seen a little bit of the money trail today. Follow the money trail. That's how you do a lot of math out there. It's all about money. That's why math is so important. Well, there are other things too that math does besides money, but that's one of the best practical applications. Hey, by the way, remember we are around this weekend on Facebook, and we're also there. There you go. And you can also still submit questions to us. Mathline at TNLearn.org. Comments, whatever. I hope you're having a good time with it, and like us there. And also, this show will probably pop up on YouTube again. And there it is, www.youtube.com. Take care of us there, and we'll be back live on Monday. See you then.